All right, December the 7th through the 11th, lesson 25. Let's kind of look at this. We're going to learn why two triangles satisfy the angle side or the hypotenuse leg congruence criterion must be congruent. And we're also going to learn why any two triangles that meet the AAA or the SSA criteria are not necessarily congruent. All right, so let's look at our opening exercise. It says, write a proof for the following question. Once done, compare your proof with a neighbor. Well, obviously you don't have a neighbor. If you do have a neighbor then that is in geometry class, then go ahead and compare that. But, you know, we're not in class, so we're just going to look at this. It says we are given that DE is equal to DG. So we're given that DE is equal to DG. And we're given that EF is equal to GF. We're given that EF is equal to GF. Alright? They want us to prove that segment DF is the angle bisector of angle DEDG. Alright, so they want us to prove that this segment here is the angle bisector. Remember, that means it divides our angle into two equal parts of angle EDG. So this angle here, they want us to prove that these two parts are equal. Alright, so let's go ahead and start with our given information. So we're given DE is equal to DG, and that is given. And we are given that EF is equal to GF. Reason is given. Oh, I guess I should have written it down here, but that's okay. We'll just, you can write it down here, or you can write it where I'm writing it. It's fine. Alright. Looking at this, what else do we know is given? If you think about DF, DF is part of both triangles, so therefore I can prove that DF is equal to DF by the reflexive property. Alright, so now let's look at this. Look at what I've got. I've got a side in this triangle congruent to this side, a side here congruent to this side, and this side is congruent to itself in both triangles. So now I can prove that the triangles are congruent by side, side, side. So triangle DEF is congruent to triangle DGF by side, side, side. One of the first things that we learned about proving triangles congruent. Now, since we know that they are congruent triangles, we know that every part of that triangle is congruent, which means that I can prove angle EDF is congruent to angle GDF by that CPCTC. Congruent parts of congruent triangles are congruent. Alright? In other words, all this says right here is that every part of those triangles are congruent, because we know that those triangles are congruent. So now, if I have proven that this angle is congruent to that angle, then I can say that DF is the angle bisector of angle DEDG, and that's the definition of an angle bisector. Because an angle bisector is, the definition of an angle bisector is a bisector is a segment that divides an angle into two equal parts. Okay? So that's all there is to that. Alright, so let's look at our exploratory challenge. It says, today we are going to examine three possible triangle congruence criteria. Angle, angle, side, or the AAS, side-side angle, or the SSA, and angle, AAA. Ultimately, only one of the three possible criteria will ensure congruence. Alright, so we're going to look at the angle, side, angle, triangle congruence criteria. It says given two triangles, ABC and A prime, B prime, C prime, if AB is equal to A prime, B prime, the side, and the measure of angle B is equal to the measure of angle B prime, which is our angle, and the measure of angle C is equal to the measure of angle C prime, which is our angle, then the triangles are congruent. Alright, so here's our proof. Consider a pair of triangles that meet the AAS criteria. If you knew that two angles of one triangle correspond to and were equal in measure to two angles of the other triangle, what conclusion can you draw about the third angle of each triangle? Alright, since the first two angles are equal in measure, the third angles must be equal in measure. Alright, so since this angle is equal to that angle, and this angle is equal to that angle, think about it, guys. We know that the three angles in a triangle equal 180 degrees. So let's just think about this for a second. Just think that, we'll say that this is 40, and we'll say this is 110. So 110 and 40 is 150. So this has to equal 30. Okay? So we know that these two angles are equal, so that means this has to be 110. We know this has to be 40 because they're equal. So then 110 plus 40 is 150, plus or minus 180 means that that has to be 30. So right here it tells us, and I don't know that these are the exact measures, I'm just using numbers to show you what this is saying. So we know since the first two angles are equal in measure, then we know that the third has to be equal in measure. Given this conclusion, which formally learned triangle congruence criteria can we use to determine if the pair of the triangles are congruent? Alright, so looking at this, what can we use? Well, if you think about it, angle, side, angle. So here, we know that we can use the angle, side, angle criteria. Therefore, the angle, angle, side criterion is actually an extension of the angle, side, angle, triangle congruence criterion. Alright? Note that when using the angle, angle, side, triangle congruence criteria as a reason in a proof, you need only state the congruence and AAS. Okay? So, we have side, 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 angle, side, angle, side, angle, and now we are adding angle, angle, side. Okay? Alright, so these are really important. Hypotenuse leg triangle congruence criteria, the HL. Alright? Given two right triangles. Now this is important, guys. When we are dealing with the HL congruence criterion, that means we are dealing with right triangles, because that's where when we have a hypotenuse and a leg, we know those are two terms that are associated with right triangles. Alright, so given two right triangles, ABC and A prime, B prime, C prime, with right angles B and B prime, if AB is equal to A prime, B prime leg, and AC is equal to A prime, C prime, the hypotenuse, then the triangles are congruent. Alright, so let's see what this is telling us. As with some of our other proofs, we will not start at the very beginning, but imagine that a congruence exists so that triangles have been brought together such that A is equal to A prime, all right? So they have marked that, and C is equal to C prime. They've marked that. The hypotenuse acts as a common side to the, actually they didn't mark C and C prime. All right. The hypotenuse acts as a common side to the transformed angles. Okay. So let's think about this for just a second. We need to make sure we understand the terminology that they are using here. When we deal with a right triangle, okay? When we deal with a right triangle, the side across from the right angle is what we call the hypotenuse. You should know this, but just in case, I want to go back over it. The side across from the right angle is what we call the hypotenuse. And then these are what we call the legs. All right? So the two sides that meet together at the right angle, those are your legs. All right, so it's important to make sure you understand that. Similar to the proof for side, 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 we add a construction and draw B prime. Okay? Triangle AB prime is isosceles by definition. Alright, so we're looking at triangle AB prime. This small little triangle here. This is an isosceles triangle because we know that two sides are equal, then it must be an isosceles triangle. So we can conclude that the base angles of ABB prime and angle AB prime B are equal. Alright, so we know that this angle is equal to this angle. Since angle CBB prime, this angle here, and CB or B prime B, this angle here, are both the complements of equal angle measures, they too are equal in measure. Okay, so let's talk about that for just a second. Both of these angles are right angles. So we know that they are equal to 90 degrees. Okay. Now, since we added this auxiliary line here, a new construction, all right, we have divided this into several different triangles. We know that this is an isosceles triangle, which means that this angle right here is equal to this angle right here. So let's say that that angle is 30 degrees. Since this whole entire angle is a right angle, then we know that the other part of it must be 60 degrees. Same here. So now we know that these two angles are equal. Okay, and that's all that sentence is telling us. Furthermore, since the measure of angle CBB prime is equal to the measure of angle CB prime B, these two angles that we just said were congruent or equal, the sides of triangle CBB prime must be equal in measure because, remember, if we've got equal angles, then we know that we have an isosceles triangle. Alright? Because what do we know about the base angles of an isosceles triangle? We know that they are equal. So if my base angles are equal, then that must mean I have an isosceles triangle. Alright. Then, by SSS, we can conclude that triangle ABC, this triangle here, is congruent to triangle A prime, B prime, C prime, this triangle here, by side, side, side. Note that when using the hypotenuse leg triangle congruence criteria as a reason in a proof, you need only state the congruence of HL. Criteria that do not determine two triangles are congruent, alright, are side, side angle and angle, angle, angle. These do not, guys, make sure you understand this. They do not determine. Alright, so we've added another one to our thing here. These two do not. And let's look at why. Okay? Side-side angle observes the diagrams below. Each triangle has a set of adjacent sides that measure 11 and 9, as well as a non-included angle of 23 degrees. Yet the triangles are not congruent. Okay? So look at this. I've got a side that's 11, I've got a side that's 9, and I do have an angle. But looking at those triangles, I can see that they are nowhere near the same. Alright, so they are not congruent triangles. Look at this small angle here. Alright, so I cannot use the side-side angle theorem. Examine the composite made of both triangles. The sides of lengths 9 each have been dashed to show their possible locations. The triangles that satisfy the conditions of side-side angle cannot guarantee congruence criteria. In other words, two triangles under SSA criteria may or may not be congruent. Therefore, we cannot categorize SSA as a congruence criterion. Alright, so we cannot use that because we don't know. It may or may not. Alright? The other one is angle, angle, angle. A correspondence exists between triangle ABC and triangle DEF. Trace triangle ABC onto patty paper and line up corresponding vertices. Alright. I'm not really sure where they're talking about those triangles because we don't have triangles. But that's okay. Let's think about this for just a second. I can have, so let's just say that this is what I know. Let's just say this is what I know. Let's say this is triangle ABC, and that this is triangle DEF. Okay? I know that angle B is congruent to angle E. I know angle A is congruent to angle D. And I know angle C is congruent to angle F. So I want to know, are the two triangles congruent? Based on your observation, why isn't AAA categorized as congruence criteria? So why can we not use AAA to prove that these two triangles are congruent? Is there any situation in which AAA does guarantee congruence? Look at this. Even though, and it goes on to say, even though the angle measures may be the same, the sides can be proportionately larger. You can have similar triangles in addition to a congruous triangle. Alright? So look, even though I have congruent angles, my sides are nowhere near the same measure. Alright? So therefore, these triangles are not congruent. They are not congruent. So list all of the triangle congruence criteria here. We need to list everything that we've learned. What we can use side, side, side. We can use side, angle, side. We can use angle, side, angle. we can use angle, angle, side, and we can use hypotenuse, leg. Okay? List the criteria that do not determine congruence here. This would be our side, side angle, and our angle, angle, angle. Alright, and please make sure you understand they do not determine. They do not determine. Alright, so let's look at these last two questions. So we are given that segment BC is perpendicular to segment CD. We are given that segment AB is perpendicular to segment AD. We are given the measure of angle 1 is equal to the measure of angle 2. Alright? So we have a lot of given stuff here. Let's go ahead and write down our given. And I'm going to, you can create 3 different steps here, or you can do them all in one step. I'm going to do them all in one step, just to save myself a little bit of room. And that's all given. Now let's talk about what we know. Okay? Let's talk about what we know. If they are perpendicular, what do we know about these angles? If I know that BC is perpendicular to CD, then I know that where those two come together, we have a right angle. Alright? If AB is perpendicular to AD, then I know that I get a right angle. So, you can maybe think about HL here, but don't jump to the fact that we have a right triangle, so we're going to use HL. Okay? Now it says we know that the measure of angle 1 is equal to the measure of angle 2. Alright, and those are exterior angles. Alright, now let's look at this. I've got 2 triangles here. What do I know? Well, I automatically know about one side of those 2 triangles. I know that BD is equal to BD. Why do I know that? Because of the reflexive property. Alright? It is the same thing. It's a mirror image of itself. Alright? So therefore, I know that that is true. Alright, now let's think about what else do we know. Now, I do not have any angles anywhere. There's not a whole lot I can do about sides right this second. So, I need to think about angles inside of my triangles here. So let's look at measure of angle 1. I can look at the inside angle and the measure of angle 1, and they would form what? They would form 180 degrees. So the measure of angle 1 plus the measure of angle CDB equals 180 degrees. Alright? And that's because linear pairs form supplementary angles. Okay? So I know that's 180 degrees all the way across there. Now, look at measure of angle 2. What else do I know? I also know that that is a linear pair. So the measure of angle 2 plus the measure of angle ADB is equal to 180 degrees. And once again, linear pairs form supplementary angles. Okay? Now, since I've done that, let's look at this. what do I know about the measure of angle CDB and the measure of angle ADB? If I already know, so let's think about this for just a second. Let's just say that the measure of angle 1 is 150. That means the measure of angle 2 is 150. Well, if these are a linear pair, then that means that this angle has to measure 30, and this angle has to measure 30. So since they both measure 30, then I know that those two angles are equal. Alright, so the measure of angle CDB is equal to the measure of angle ADB, because if two angles are equal in measure, then their supplements are equal in measure. Alright? If two angles are equal in measure, then their supplements are equal in measure. Alright, so now we know that we've got this. Okay. Alright. Now, let's go back to this for just a second. We have not stated anything about these two angles. But what do we know about those? Well, once again, if we know they're perpendicular, they form right angles. Right angles are equal to 90 degrees. So the measure of angle BCD is equal to the measure of angle BAD, which is equal to 90 degrees. Alright, so we're kind of stating it all at once. We're saying, okay, both of those angles equal 90 degrees, so if they both equal 90 degrees, then they're both equal. Alright, and that's the definition of perpendicular line segments. Alright, so now, look at what we've got. Remember, let's stop. Okay, so do we have, let's see if we've gotten far enough to prove. Alright, so can we use side, side, side? We've only proven one side, so that's not going to work. This one's not going to work because we've only proven one side. Alright? Angle, side, angle. Remember, it has to be angle, and the side has to be between the two angles. So angle, side, angle, that's not going to work. Alright, can we prove angle, angle, side? Angle, angle, side. We have proven this using the angle, angle, side, so we are finished. So triangle BCD is congruent to triangle BAD by angle, angle, side. Okay? So there we go. We've proven our triangles. Alright, number 2. Segment AD is perpendicular to segment BD. Alright, so AB is perpendicular to, let's see, AD is perpendicular to BD, so we know that that's a right angle. BD is perpendicular to BC, so we know we have a right angle here. And we know that AB is equal to CD. Alright? So once again, I can just do a whole entire step for my givens. So AD is perpendicular to BD, BD is perpendicular to BC, and AB is equal to CD. That is all my given information. Alright? Now, let's think about this. I want to prove that triangle ABD is equal to or congruent to CDB. I want to prove these two triangles congruent. Alright, so, we might be able to use HL here. In order for us to use HL, we have to prove that we have right triangles. Can I prove that I have a right triangle? Well, I can because of these perpendicular segments. So, I can say that triangle ABD is a right triangle. The reason is, it's the definition of perpendicular segments. If I know I have perpendicular line segments, then I know that I have a right angle somewhere. Alright, so now I can prove that triangle CDB is a right triangle. Same thing here, definition of perpendicular line segments. Okay. Alright, now, what else do I know here? Alright, guys, look at this. What do I know about segment BD? Segment BD is part of both triangles. So I can automatically go ahead and say that BD is equal to BD because of reflexive property. Alright. Now, let's look at this. I have proven the hypotenuse of both triangles congruent. I have proven a leg of both triangles congruent, so therefore I can prove that triangle ABD is congruent to triangle CDB by HL, the hypotenuse leg. Alright, short lesson this week, but full of information. Please make sure that you are reaching out if you need any help at all. Reach out to me, call the school, Google Classroom. Guys, however you can get a hold of me, do it. Email me, all right, if you need help. Hope you have a great week.